traffic used to be fairly predictable, right? You said it was static, it was all carved up in little pieces. With growing mobility, with cloud computing, traffic patterns are moving rapidly. And you have to have an infrastructure that can flexibly absorb these peaks and valleys and these different chunks of bandwidth that will be rerouted. So you got the whole challenge of today's infrastructure, which has this big fixed transport pipes, and then you have an aggregation network. It becomes more difficult to aggregate traffic that is highly dynamic. Sure. Right? 5 years ago, as we discussed before, we knew exactly where everybody was because everybody was physically connected. Now people watch movies on trains. People watch movies anywhere, right? I was here today, yesterday in my hotel, I was doing what I normally do in Sunnyvale. So I'm changing or creating big shifts in traffic pattern, and the network needs to be able to absorb that.
Yeah, the LTE network, again, all the LTE that we're deploying, huge amounts of bandwidth, where before that was a pretty limited amount of bandwidth that you had to move around. We did it with DS1s connecting to cell towers. Now we're using a lot of 4100s and 9500s to backhaul that traffic because it's measured in hundreds of megabits, not just in DS1s.
Yeah, and it's rapidly becoming gigis and 10 gigis in many networks.
That may be another application for just an ODU0. Take a very simple pipe all the way to the cell tower.
Yeah.
But they're really, what it is in that part of the network is really about optimizing your investments, optimizing the cost structure, right? It's about saving money. At the edge of the network, it's about making money, right? And that's a whole different ballgame.
That's why I always say I think I picked the wrong area of the company to work in. I've always been in a transport layer, and everybody says, how do you do more for less? Right. It's at cost at the end of the day. You wonder why the pressures are what they are on us transport guys. It's because it's the cost of doing business, it's connectivity, but unfortunately you just can't charge enough for connectivity. I wish we could.
Yeah, it's a challenge of how would I say, increasing the perception of value of the asset you have in the transport network. Because, everybody talks about putting things in the cloud and the value of cloud-based services, but virtualization, but, as you joked about it 20 years ago, Centrix was a cloud service. But without a network, the cloud can't operate. So the challenge is, how can you use that very valuable asset you have to bring value to the people that offer services in the cloud, or potentially even venture into offering those services yourself?
Yeah.
Because the biggest challenge you have today is over-the-top traffic, which hits your network from anywhere. Today anybody can start a service company. All you need to do is either buy your own servers or you lease servers from an Amazon,
you don't even have to buy the servers.
Right, so you need a pipe into the network, which is pretty much your only cost structure, because you know that you'll be able to use somebody else's network.
Right. The barrier to entry is very, very low, which means there's lots and lots of people doing it, which means there's lots of competition. But back to your point of having an open network or open systems, that's where a lot of the innovation is happening. There's a lot of great, if we had to sit down and try and develop every application that goes on an Android phone, we knew we couldn't get there. We couldn't be as competitive if it would let everybody else do it and then provide the means for them to do it. I think the trick is figuring out how to make a dime along the way. How do you spend more money? How do you rationalize that? How do you come up with a good business case that says I'm going to spend X number of dollars to make this transport infrastructure more dynamic, therefore I can provide new services at a lower cost, or perhaps better performance than anybody else. That's one of the areas that you probably can do better, because if your pipe, regardless of how big it is or how dynamic it is, if the user experience is better, if the perception is better, he's willing to pay more, even because he won't get that same.
And that's where we believe that increasingly transport networks, the fundamental or the actual, the way you'll carry information will ultimately be more packet-based. You'll have the transport pipes, so you'll always have an OTN infrastructure, which is that flexible infrastructure, which is your wavelength network, your pure transport network, on which you will layer things like LSPs, which are virtual circuits, but they're circuits, and they can be managed in exactly the same way as you manage your OTN network today, but they're optimized to carry packets. which is where all the services are going to. So you can size these LSPs in different forms. You can put them in native ODU4s, or you can put them in ODU2s if you basically want to have more granularity in that transport network. But I think the advantage is that with this control plane consolidation, all of these layers know what's going on in other parts of the network, and you can do things more proactively. You know, if you know that, you know, you see a prefetch error rate going up, you know, the routing layer can start proactively rerouting some of your most important connections. That's where you can start looking at class of service. You said the people that pay the most are the ones that are rerouted first.
Yeah, because we didn't talk in, you know, we were, and even on sunny day scenarios, it's difficult enough with the mobility of the traffic and the varying demands. But then you put into it outages and things like this, robustness of the network, because a lot of times that's when the network gets stressed the most, is when there is an outage, because that meant some type of disaster. That was either weather related or some type of event that caused a lot of extra traffic on the network when it's the most vulnerable because of outage conditions.
That's when you find out how robust your
That's when you find out how robust it is, right?
And that's really where you have to have something that is flexible enough to do, you know, ad hoc aggregation, dynamic rerouting, you know, try to make your bandwidth as flexible, as liquid as possible. Because otherwise you get again into this issue of, well, if I have to over provision to account for every single failure, you really don't have a business case.
Yeah.
Because you're going to deploy a lot of assets that are not going to be used.
Right, those 100G pipes sitting around at the price of a very, very nice car sitting there doing nothing.
Right.
Isn't a good model.
And with this increased, you know, as you said, increased peak to average ratio, that makes it worse. We've had service providers say that even in the core of the network where flows are aggregated, they're seeing peak to average ratios grow year over year. They say, you know, this was one operator in Europe who said, like 5 years ago it was 1.25 to 1. Today we're close to 2 to 1. It's growing about 0.25% year over year. So you see more peaks and valleys in that, even in the core of the network. Right. So you have to have a technology that allows you to use that bandwidth better, and disassociate cost from value you can create, right?
Right.
So
right.
To better, you know, we call this CapEx efficiency. You know, how efficient is the money you put into that network? You know, what is the revenue potential that you put into that network?
Right. Those services on the top, those packetized services, as you say, are driving the revenue. They're driving the top line, but unfortunately, there's only so much revenue that generally comes in the door. You need to somehow cut the cost while you're doing that. And of course there's hammering down new technologies or getting the cost of 100G to come down, but there's a trend for that, and that'll happen. But if you're using less of them, that's the easiest way to cut it. If you're using it more optimized.
Yeah, and that's where things like caching come in, right? You know, video is always the big culprit here, right? Everybody talks about, you know, Netflix and other video services consuming so much bandwidth. So one of the strategies would be, well, let's try to put these, you know, video distribution, content distribution as close as possible to the user, because if you can avoid having to stream the same video 200,000 times a day, and you know, these streams are all anything between 3 megabytes and 20 megabytes or so, you would save a lot of resources in the network. The challenge is, how do you do that cost efficiently? Intuitively, everybody knows I can save money with caching. But making a business case is very difficult, because you have to have so much intelligence to do your caching well. You have to figure out what is the shelf life of a video. You know, are people watching it for 5 days? After 5 days, you start pulling it into the network again, because you may have to make room for another one. So this is another one.
Next flavor of the month. But the problem is, how do you get? I mean, one of the things you got to avoid, and we've made this mistake too sometimes, is that we almost built a network on top of the network to control it. And pretty soon that control network, today that's all the management systems in the back office, are arguably the bottleneck and the cost structure behind it. In many cases, it costs as much as the infrastructure. Yeah. And that's the part we need to avoid, is that we're not just shifting that cost away into a very, very expensive control plane. You know, it has to be straightforward enough to where it's built into the equipment, so that we don't have a whole new network operating this, you know, to try and optimize
Yeah, and that's again why you want to consolidate equipment as well, because they're all using common components, and you don't want to replicate those components in different pieces of hardware, because then you have to basically consolidate them. You have to correlate them, which is difficult. So if you have devices that share common control planes and common hardware, and you can expose these different parameters around flow information, packet information, quality information, whether it's video or voice, you can use that, you can process that locally before you're ultimately sending it over your management network.
But common control plane, that's not simple, right? I mean, it's going to take a lot of work between the vendor community, to be sure that they actually work together.
Yeah.
I mean, there are a lot of standards out there, but there's also a lot of, nuances at implementation. Yeah. So it's going to take a lot of, I think, tight intercoupling in an ecosystem within the vendor community to make the operations model actually easier.
Right, to make the operations model easier.
Otherwise, you're going to have another management layer to manage the control plane, because they're different in different domains, and that's not going to buy anything.
That is where the service provider community can come into play and try to enforce that, right? Because you mentioned the cell phone model, the Android versus the Apple OS. Each of those have massive amount of application developers. Now, Android is obviously more open than Apple, but you have a community, you have an ecosystem. You can create the same in your access network. It's just that you have to convince these vendors to allow this ecosystem to be built, to have certain platform standards, to have certain interconnection standards. And then you can start collapsing different pieces of hardware, different pieces of software, because you have common ways of exposing information that people can use in certain ways.
I think that's happening in the access and metro networks, right? I mean, at least from a transport perspective, we've got, there's GPON, there's HFC, there's connection-oriented Ethernet that we use, for access, various flavors of Ethernet, and other access technologies that get us to that first common point. And at that first common point, we can extract the data from those various media types, whether it's DSL or it's, ultimately it all ends up being an Ethernet connection over something, right? So the consolidation is happening at the transport layer. Now what'll be interesting is to extend that into the management layer.
And that's where Ethernet has come a long way, right? First generation was just LAN-based. It was not even the best technology around, right? People would argue token ring was better, but it's not always the best technology that wins. That first generation was followed by a second generation, which tried to make Ethernet more carrier grade, but it was very focused on either, delivering new services or saving money. We call it the tyranny of or. It was or saving money or creating new applications. Now Ethernet is smart enough that you can actually collapse systems, you can open systems up, you can have third parties develop applications to run on your machines, all using that same infrastructure. All it takes is the goodwill and the commitment of the vendor community to work together. And as I said, people will find that part of the network, that part of that ecosystem where they can thrive. It's very difficult to do everything.
Yeah, this is the problem. Not everybody does everything well. And, everybody has their strong points, but interoperability gets the best of us every time. I mean, the network's made of many moving parts at the same time. That interoperability is our single biggest issue. It's the one that keeps our lab guys up all night long testing, as opposed to the boxes themselves are getting more and more robust. The technology itself is getting more robust. What we put into them, the hardware, the software, the operating systems are a heck of a lot better than they used to be. But it's the interoperability between all of those different boxes that is already challenging at layer one.
It's not getting any simpler.
Yeah, right. We're making it even worse. OTN, like we say, is probably the great way, but right now we've got like 14 projects in the lab on OTN testing to try and do interop, because it's an n squared problem. As soon as you have, more than two suppliers, if you've got two of each, and if you've got two router suppliers and two transport suppliers, now that control plane has a bigger problem than it would be even if it was just one.
Now,
so
you you open up another discussion point around interoperability, right? There's actually an opportunity to drive interoperability much farther than where it is today. With the increased use of electronic processing in devices, you can create ways to interoperate equipment and still leave room for individual vendors to create value. Because very often, a lot of your costs are associated with the fact that you cannot interoperate this equipment with that equipment.
Yeah, so we need another piece of equipment in between.
And then you need a piece of equipment in between, or you need multiple vendors. So now you have multiple vendors in the network, each doing different parts in the network because you cannot interoperate them.
Well, and that's why things are so split the way they are, right? You have individual domains that within those topologies or those pieces of the network, they tend to be homogeneous from a vendor perspective. Everybody wants to dual source or triple source on their vendors, but to have to have backups and in order to operate right. But within that infrastructure, you still end up with islands, because there's always an interoperability question mark.
But personally, I believe that it's something that is going to happen. You can't stop that from happening. We've seen it in other industries, right? Voice band modems used to be all proprietary. In the early 80s, with the advent of DSPs and digital processing, and everything became electronically processed, it took about a decade to literally make that industry into something that was sitting inside your laptop. We've seen that happen in the wireless world too. We've seen it happen with DSL. I think once you go digital and ASICs and everything becomes processing and handshakes and agreements, there's no way you can stop interoperability.
Maybe.
And then you can take two positions, right? You can fight it, or you can lead it. And that's going to be one way to take the cost out of your network.
Yeah, it's one that we've
seen it happen with Ethernet, right?
It's absolutely necessary.
You can walk in any hotel room in the world. You have a jack. You can plug it in, and it's going to work. Right?
Yeah, it's the beauty, right?
Mm-hmm. So if you could say, I have
$100. It costs you $12.95. In other words, it's free.
It's free.
So that's what we need to do is figure out how to do it for $12.95.
But if you could say, I have a 100 gig interface coming out of this device and a 100 gig interface coming out of that device, I can interoperate these two over 1,000 kilometers.
It's a lot of physics to get at that 1,000 kilometers.
Yeah. It is, but...
Yeah, but so I do agree, and we want to get there, but I guess you think it'll take a decade then? If that was your prediction.
And maybe that's how control plane evolves. We implement control plane within a domain, and then we, in the optical layer, and then we start to interop then between the domains in the optical layer, and then we start reaching up, and now we interoperate to upper layers.
Yeah, but
maybe there's a progression there, much like other technologies.
And physical interoperability is also going to make your management problem easier, because you'll know exactly what parameters to monitor. Right now, very often, you have multiple management systems because all these systems are proprietary. People measure different things.
Sure.
People react to different things, and that's really where the complexity is. It's very difficult to find common grounds in
Yes. So what
it
means is that we do protection at physical layer and at the electrical layer. So we're doing it twice.
Yes.
Just because we couldn't figure out how to optimize in between them.